Okay, next very important concept, rotating magnetic field. I already told you, I already initialized you. Generally, in our AC machines, we have two parts. One is called as stator and another one is called as rotor. When three-phase AC supply given to the stator, then automatically it produces a magnetic field which rotates in clockwise direction with synchronous speed. It produces the magnetic field which rotates in clockwise direction with synchronous speed. That's why this magnetic field is called as rotating magnetic field. I told you it is magnetic field which rotates in clockwise direction. How? How can you say that? Is it is rotating or stationary? How can you decide? Let's see. For example, I'm taking a three-phase supply. I'm taking a three-phase AC supply. Three-phase AC supply. For example, right? Let's take for example this is R phase and Y phase and B phase. I've taken three phases, which is this is the maximum value for each phase. Maximum value, maximum flux nothing but phi m. And here also this is the maximum value nothing but phi m. For example, I taken the three-phase AC supply here. Now, for example, generally in three-phase system, the three phases are displaced by 120 degrees each other. We know that. In three-phase system, the displacement between two phases is 120 degrees. For example, this is my R phase, and for example, this is my Y phase, and for example, this is my B phase. This R phase and Y phase displaced by 120 degrees, and my Y phase, B phase also same, and B phase, R phase also same. Each phase displaced by 120 degrees each. Nothing but 120 degrees each, nothing but, for example, phi R is equals to the mathematical expression for phi R. Tell me, sir, what is phi R? Phi R is equals to phi m into sine omega t. For example, another phase phi y is equals to phi m into sine omega t minus 120 degrees. Because 120 degrees displacement, this is minus 120 degrees, right? What about next phase? Phi b is equals to phi m into sine omega t minus 240 degrees. Because this is 120 plus this is 120. Finally 240 degrees up to here. 240 degrees. But this minus 240 is also written as plus 120 degrees. Yes or no? Actually, this is 120 and this is 120. Finally, 240 degrees. Okay. But see here, in negative direction, this is also 120 degrees. That's why this can be also written as omega t plus 120 degrees. These are my three phases, phi r, phi y and phi b. Phi m into sine omega t, phi m into sine omega t minus 120 degrees, phi m into sine omega t minus 240 r plus 120 degrees. These are the three phases, R phase, Y phase and B phase. Y phase, B phase, like that. Now, I am going to find out the resultant flux. The resultant flux is equals to the phi r plus phi y plus phi b. Now, I am going to find out this resultant flux. Generally, we have a formula to add two vectors. For example, we have only two vectors. How we can get the resultant value? The phi r is equal to square root of phi 1 square plus phi 2 square plus 2 phi 1 phi 2 cos theta. We know that formula. But we don't have a formula to add three vectors. Is there any formula? There is no any formulas to add three vectors. But even though we have to add three vectors, how? We have a small trick here. Let's see here. This is generally omega t is equals to 0. And this is omega t is equals to 60 degrees. And this is omega t is equals to 120 degrees. And this is omega t is equals to 180 degrees. These are the points. 0 degrees, 60 degrees, 120 degrees and 180 degrees, like that. Once observe here clearly, at omega t is equals to 0, the R phase is equals to 0. Yes or no? What is my R phase at omega t is equal to 0? 0. What is Y phase? Y phase is negative some quantity, not 0, not maximum. What is B phase? B phase is in positive, not maximum, not 0. Some quantity, it has some quantity. At omega t is equals to 60 degrees, see here, the B phase is equals to 0. At omega t is equals to 120 degrees, Y phase is equals to 0. At omega t equals to 180 degrees, again R phase 0. Nothing but at omega t is equals to 0, we have only two fluxes, phi y and phi b. At omega t equals to 60 degrees, it's already B phase is 0. That's why we have only two fluxes, phi r and phi y. That is the trick. Now we have to find out resultant flux at omega t is equals to 0 degrees, at omega t equals to 60 degrees, at omega t equals to 120 degrees, and omega t equals to 180 degrees, and etc. Right. First, at omega t equals to 0 degrees, can you tell me phi r, the flux of the R phase? Tell me, what is R phase flux here? 0, sir. Mathematically, if omega t is equals to 0, see here, if omega t is equals to 0, what is phi r? Phi r is equals to phi m into sine 0. Sine 0 is equals to 0. That's why phi r is equals to 0. Yes? Yes or no? Right. What about phi y at omega t is equals to 0? If omega t is equals to 0, we have here only minus 120 degrees. What is sine minus 120 degrees? Minus sine 120 degrees. Minus sine 120. Sine 120 nothing but 90 plus 30. 90 plus nothing but here 90 minus. Here 90 plus. Nothing but second quadrant we have a 90 plus. In second quadrants, sine value positive or negative? Here silver. All silver tea cups. According to that trick, here silver, that's why the sign is positive only, right? Sign is positive only. So sin 90 plus 30 is written as cos 30. 90 plus theta. Sin 90 plus theta, cos theta. So what is the value actually? Phi y is equals to phi m into sin omega t minus 120 degrees. Nothing but minus phi m into sin 120 degrees. Nothing but minus phi m into sin 90 plus 30 degrees. Right? Getting or not? Finally, minus phi m into cos 30. Minus phi m into cos 30. And finally, minus cos 30 nothing but root 3 by 2 into phi m. What is our final answer? Minus root 3 by 2 into phi m is my final answer for phi y. Okay? Getting or not? Phi m into sin omega t 0. I told you already, omega t is 0. 0 minus 120. Nothing but minus sin 120. Nothing but minus phi m into sin 90 plus 30. 90 plus 30 is the second quadrant. In second quadrant, sign positive only. That's why sin 90 plus 30 can be written as cos 30. We know that cos 30 value root 3 by 2. Root 3 by 2 into phi m with negative. Right. We have a value. We have a value here. Finally, I'm taking the answer minus root 3 by 2 phi m. Minus root 3 by 2 phi m. What about phi b? Can you tell me phi b? Phi b is equals to. Phi b is equals to. Now tell me what is phi b? Phi b is equals to phi m into sin omega t plus 120. Nothing but 0 plus 120. Here 0 minus 120. Here 0 plus 120. Can you tell me what is final answer? Just here minus is there. Now we have just plus sign into root 3 by 2 phi m. Here we have a minus value because sin minus 120. But here we have a sin plus 120. That's why minus root 3 by 2 phi m plus root 3 by 2 phi m. Actually, this is very easy to represent in this waveforms. See here once. This is phi r is equal 0. I told you already. Phi r is equal 0. I told you already. And what about phi y? See here. Phi y is in negative. Phi y is in negative. That's why minus root 3 by 2. This value root 3 by 2 with negative sign. Negative root 3 by 2. That's why minus root 3 by 2 phi m. And what about phi b? See here B phase. B phase in positive. B phase in positive. What is the value? Root 3 by 2. So, what is phi b? Phi b is equals to root 3 by 2 phi m. Phi b is equals to root 3 by 2 phi m. Now, can you tell me at omega t is equals to 60 degrees, what is phi r? At omega t equals 60, what is phi r? Once you see here, phi r is equals to phi m into sin 60. Phi r is equals to phi m into sin 60. What is sin 60? Root 3 by 2. So tell me what is phi r? Root 3 by 2 phi m. Yes, have a phi r. Can you tell me what is phi y here? What is phi y, sir? See here, phi m into sin 60 minus 120. Nothing but phi y is equals to phi m into sin 60 minus 120 minus 60. Sin minus 60, what is the value? Minus sin 60, sir. Minus sin 60. What is sin 60 again? Root 3 by 2. That's why minus root 3 by 2 phi m. Okay. What about phi b? Tell me what about phi b? See here. Phi b is equal to phi m into sin 60 plus 120. What is the value of 60 plus 120? 180. What is sin 180? 0. If sin 180 is 0, what is phi b? 0. Phi b is equals to 0. This is very easy to represent in this waveform. At omega t is equal to 60, see here, R phase in positive, R phase in positive, and see here, Y phase in negative, Y phase in negative, Y phase in negative, and at omega t equals 60, the B phase is equals to 0. At omega t equals 60, the B phase is equals to 0. Omega t equals 60, R phase positive, Y phase negative, and B phase 0. That is I written here. Now can you tell me at omega t equals to 120, what are the values? At omega t equals to 120, what about phi r? At omega t equals to 120, phi r is in positive. Phi r is in positive. R phase is positive, sir. What is the value positive? What is the value? Plus root 3 by 2 phi m. Right. At omega t equals 60, what is Y phase? Let's see here. What is Y phase? Y phase is 0. Y phase is 0. At omega t is equals to 120, what is B phase? At omega t equals 120, the B phase is in negative. At omega t equals 120, the B phase is in negative. That's why minus root 3 by 2 phi m. Minus root 3 by 2 phi m. So, at omega t equals 0, at omega t equals to 60, at omega t equals to 120, I written here. Right. At omega t equals 180, you can tell easily. At omega t equals 120, R phase is 0, Y phase is in positive, and B phase is in negative. You can write all those. Right? These are at omega t equals 0, at omega t equals 60, at omega t equals 120, the different fluxes. I told you, I have to find out the resultant vector of 3. Resultant flux of the 3 phases. What is the resultant flux of these 3 phases? Here already R phase 0. That's why the resultant flux of 3 phases nothing but the resultant flux of these 2 phases only. Here also. At omega equals 60, actually I want resultant flux of 3 phases. But here already B phase is 0. That's why the resultant flux of 3 phases nothing but the resultant flux of these 2 phases only. What is resultant flux here? Again, the resultant flux of 3 phases nothing but the resultant flux of these 2 phases only. We have a formula to find out the resultant flux of 2 vectors. What is that? Phi resultant is equals to square root of phi 1 square plus phi 2 square plus 2 phi 1 phi 2 cos theta. Let's do the resultant vector or resultant flux for these 3 situations. Right? Let's see. Okay. Now, just we written the values of each phase. The values of each phase at different instantaneous. At omega equals to 0, 60 and 120. Now, let's do here. What is our aim? To find out the resultant flux. Right? Let's draw the diagram for this first of all. Here, my flux in R phase is equals to 0. My flux in R phase is equals to 0. What is my flux in Y phase? My flux in Y phase minus root 3 by 2 phi m. My flux in Y phase minus root 3 by 2 phi m. I want positive value. What should I do? If this is minus root 3 by 2 phi m and it's exactly outside, which is 180 degrees to this one, this is plus root 3 by 2 phi m, we know that. If this is minus root 3 by 2 phi m, exactly 180 degrees. In exactly 180 degrees, that vector having plus root 3 by 2 phi m. Now this is minus root 3 by 2 phi m and this is plus root 3 by 2 phi m. And we know the phase shift between R phase and Y phase is 120 degrees. And what is last one? What is my B phase value? For B phase flux is plus root 3 by 2 phi m only. So for B phase, my value plus root 3 by 2 phi m only. Now what is this angle? This is also 120 degrees. R phase to Y phase 120, Y phase to B phase 120, and what is this value? The B phase to R phase also 120 degrees. So these all are 120 degrees only. Okay, now I want to add them. Actually, I want to add this Y phase and B phase actually. But now this is I'm taking here for positive for easy analysis only. Just for easy analysis, I'm taking here. Now I'm going to add these two fluxes. These two fluxes vector sum is called as resultant flux. These two vectors, the vector sum is taken as the resultant flux. Can you tell me what is this angle? What is this angle? Actually from here to here 120 degrees. But I am taking for this exactly opposite another vector. Nothing but this total 120 degrees split into two equal parts, which is 60 degrees and 60 degrees. Right. Now I want this resultant flux value. Very important. I want this resultant flux value. This resultant flux nothing but sum of these two fluxes. Sum of these two fluxes. Now tell me, what is the resultant flux? The phi resultant is equals to square root of phi resultant is equals to square root of phi 1 square plus phi 2 square. What is phi 1 square? Tell me, what is phi 1 square? Phi 1 square is equals to 3 by 4 phi m square. Yes or no? Root 3 square 3, 2 square 4 phi m square. So this is phi 1 square plus phi 2 square. What is phi 2 square? Tell me fast. 3 by 4 phi m square. Again 3 by 4 phi m square. Phi 1 square plus phi 2 square plus 2 phi 1 phi 2 cos theta. Yes or no? So plus 2 phi 1 into phi 2. Can you tell me what is the resultant value of phi 1 into phi 2? Phi 1 into phi 2 nothing but again 3 by 4 phi m square. 3 by 4 phi m square. So 2 phi 1 phi 2 cos theta. What is theta? Theta is the angle between two vectors. What is this theta? This theta is 60 degrees. So what is cos 60? Cos 60 is equals to 1 by 2. So these two gets cancelled out. Now what is the values here? We have 3 by 4 phi m square, 3 by 4 phi m square, 3 by 4 phi m square. Can you tell me what is final value? 3 by 4 phi m square, 3 by 4 phi m square, 3 by 4 phi m square is equals to 9 by 4 phi m square. 3 plus 3 plus 3, 9. 9 by 4 phi m square. This 9 by 4 phi m square, this resultant flux is equals to 9 by 4 phi m square actually. How can we written as this one? This can be written as 3 by 2 phi m whole square. Is it okay? Is it okay? 3 square, 2 square, phi m square. 3 by 2 into phi m whole square. This square root gets cancelled. Now tell me, what is the final resultant value? 3 by 2 phi m. What is our final resultant value? 3 by 2 phi m. 3 by 2 nothing but 1.5. Yes or no? 3 by 2 nothing but 1.5 times of the phi m. So what is, I want that the final resultant flux is equals to, the final resultant flux is equals to 1.5 times of the phi m for three-phase system. For three-phase system, the final resultant flux is equals to 1.5 times of the phi m or 3 by 2 times of the phi m. This is the value same for any instant. This is the value same for any instant. Because the C here, one C here, minus root 3 by 2 phi m plus root 3 by 2 phi m. Again here, plus root 3 by 2 phi m minus root 3 by 2 phi m. Again here, plus root 3 by 2 phi m minus root 3 by 2 phi m. All the values are same, similar. That's why the resultant flux also similar. The resultant flux also similar. So, what is the resultant flux for three-phase system? For three-phase system, the resultant flux is 1.5 times of the phi m. 3/2 times of the phi m. Right, sir? Now, this is for omega t is equals to 0. Right? If we calculate at omega t is equals to 60 degrees, see here once. For omega t equals 60 degrees, what is the values? How the vectors for omega t equals to 60 degrees? Let's see here once. Let's see here. At omega t equals 60, what is phi r? At omega t equals to 60, phi r is positive, that too plus root 3/2 phi m, right? Okay. What is phi y? At omega t equals 60, my phi y is minus root 3/2 phi m. Minus root 3/2 phi m. If it is taken for 180 degrees opposite direction, its value is plus root 3/2 phi m. What about phi b? My phi b is 0. Actually, what is this total angle? Actually, this total angle is 120. But what is this angle now? This angle is 60 degrees. What is the resultant flux now? The resultant flux nothing but sum of these two. Sum of these two is taken as phi resultant. Sum of these two taken as phi resultant. Right, sir? Yes? I have a phi resultant value. Can you tell me what is final answer for phi resultant? This phi resultant is equals to again 1.5 times of the phi m. Again 1.5 times of the phi m. So up to now, what you observed here in three-phase induction machine, when three-phase supply given to the stator, it produces some flux. The resultant of the flux is 3/2 phi m or 1.5 times of the phi m. This is very, very important, but another important factor is there to observe. Let's see here. Let's see here. Here, my resultant flux is in this direction. Here, my resultant flux is in this direction. At omega t equals to 0 degrees, my omega t is, sorry, at omega t equals to 0 degrees, my resultant flux is this direction. Right? At omega t is equals to 60 degrees, at omega t equals to 60 degrees, my resultant flux is, at omega t equals to 60 degrees, my resultant flux is, actually omega t equals 0, this is resultant flux direction. At omega t equals 60, it shifted to here. And at omega t equals to 120, it will shifted to here. And at omega t equals to 180, it shifted to here. And omega t equals to another 240, shifted to here. Like that, see here, clear observation, just cover all these points, the final touch, listen carefully. At omega t equals 0, this is my resultant flux direction. At omega t equals 60, the flux direction is here. At omega t equals 120, here. At omega t equals 180, it will shift it to here. So finally, at omega t equals 0, this is my flux direction. At omega t equals to 60 degrees, this is my flux direction. At omega t equals to 120, this is my resultant flux direction. At omega t equals to 180, this is my flux direction. At 240 and again at 360 and like that, 0, 60, 120, the resultant flux is rotating like this. The resultant flux is rotating like this. That's why it is called as rotating magnetic field. Why? Because here the resultant flux is rotating. That's why it is called as rotating magnetic field. In which direction it going to rotate? In which direction? Let's see here. From here to here. From here to here. Nothing but clockwise or anti-clockwise. It is a clockwise direction, no? As the resultant flux is rotating in which direction? Clockwise direction. In which direction? Clockwise direction. At what speed? At what speed? It rotating at synchronous speed. It rotating at synchronous speed. This is very, very, very important. So final single statement. Finally, for all these, the one single statement is that in three-phase induction machine, in stator winding, the magnetic field will produces, which rotates in clockwise direction with the synchronous speed. Which rotates in clockwise direction with the synchronous speed. Now you have to draw the same diagram for omega t is equals to 60 and 120, and once check it, is it rotating or not? I already checked it at omega t equals to 0 here and at omega t equals 60 here. You have to check it. Omega t equals to 120. Where is my resultant flux? Is it here or not? At 120. At omega t equals 180, where is my resultant flux vector? Is it here or not? If it is here like that, then the flux is rotating in clockwise direction with synchronous speed. We can conclude that statement. Right, sir? Very important. Okay. Now the conclusions for this rotating magnetic field. Some conclusions. These are very, 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 very important to competitive exams, for all competitive exams. Right? Let's see. We already know for three-phase system, what is the resultant flux? For three-phase system, the resultant flux is 3/2 phi m. For three-phase system, resultant flux is 3/2 phi m. For three-phase system, 3/2 phi m. Can you tell me what is the resultant flux for two-phase system? Sir, for three-phase system, 3/2 phi m. So, for two-phase system, 2/2 phi m. That is the answer for two-phase system. Right. For two-phase system, 2/2 phi m. For three-phase system, 3/2 phi m. What about for n-phase system? N-phase nothing but 2, 3, 4, 5, 6, 7, 36 and so on. Whatever it may be. For 36 system, for 12-phase system, what is the resultant flux? For n-phase system, the resultant flux is n/2 phi m. For two-phase, 2/2. For three-phase, 3/2. For n-phase, n/2 phi m. Now, what is n here? They are asking question. What is n here? Is it equals to 1? Is it greater than 1? Is it less than 1? Or any of the above? Like that they are asking question. Actually, I told you, for two-phase system, resultant flux is 2/2 phi m. For three-phase system, 3/2 phi m. For n-phase system, n/2 phi m. What about for single-phase system? For single-phase system, phi m, sir. For single-phase system, phi m is the resultant flux. There is no any controversy. That's why this formula is not applicable for single-phase. This formula applicable for all polyphase systems. This is not applicable for single phase. That's why this n is greater than 1. If n is equals to 1, what is the value? If n is equals to 1, 1/2 phi m. This is exactly wrong answer. If n is equals to 2, 2/2 phi m. 100% correct answer. If n is equals to 3, 3/2 phi m. 100% correct answer. If n is equals to 12, 12/2 phi m. 100% correct answer. But if n is equals to 1, 100% wrong answer. That's why I told you here n greater than 1. What is that? N greater than 1. For n-phase system, resultant flux is equals to n/2 phi m. Okay, this is very important question. And another question also is there. What is the phase displacement between two phases? In three-phase system, the phase displacement between any two phases, the phase displacement between any two phases is 120 degrees. I know that. 120 degrees nothing but 120 degrees nothing but 2 pi by 3 radians. We know that, sir. 2 pi nothing but 360. 360 by 3, 120 degrees. I know that. Can you tell me what is the phase displacement? Can you tell me what is the phase displacement for n-phase system? For three-phase system, 2 pi by 3. For 3-phase system, 2 pi by 3. For n-phase system, the phase displacement is, for 3-phase system, 2 pi by 3. For n-phase system, 2 pi by n. For n-phase system, 2 pi by n. Sir, what about for 2-phase system? For 2-phase system, the phase displacement is just pi by 2 radians only. In 2-phase system, the phase displacement is 90 degrees only. In 2-phase system, the phase displacement between any two phases, nothing but we have only two phases, right? The phase displacement between those two phases is 90 degrees, nothing but pi by 2. But in 3-phase system, 2 pi by 3, 120 degrees. For n-phase system, 2 pi by n. Now tell me, what are the n values? Is it greater than 1 or greater than 2 or greater than 3? They are asking question. Tell me, sir. Is it greater than 1 or 2 or 3? For example, take 1. Not possible. For example, take 2. If n is equals to 2, what is phase displacement? 2 pi by 2, nothing but pi. Is it correct answer? 100% wrong answer. For 2-phase system, I told you that. For 2-phase system, the phase displacement between two phases is 90 degrees. But when we are using this formula, it giving that pi radians. That is 100% wrong answer. That's why n should be greater than 2. Greater than 2, nothing but 3, sir. If n is equals to 3, 2 pi by 3, 100% correct answer. If n is equal to 7, 2 pi by 7, 100% correct answer. So, this is very important. Here n greater than 1, here n greater than 2. Here n greater than 1 for this one, n greater than 2 for this. So, what are the conclusions? For 3-phase system, resultant flux is 3 by 2 phi m. For 2-phase system, 2 by 2 phi m. For n-phase system, n by 2 phi m, where n greater than 1. For 2-phase system, phase displacement is 90 degrees or pi by 2 radians. For 3-phase system, phase displacement is 2 pi by 3 radians or 120 degrees. For n-phase system, the phase displacement is 2 pi by n or n greater than 2 here. N greater than 2, 2 pi by n. Now you have one doubt. Sir, what is the phase displacement between any two phases in a single phase system? What is the phase displacement between any two phases in a single phase system? If you ask this question anyone, they will give you a Nobel Prize. Why? Because you are telling that it is a single phase. Single phase, nothing but how many phases are there? Only one phase. Again, you are asking question that what is the phase displacement between two phases? Yes or no? There is no question. There is no question asking that. Right? So, there is no possibility of question for single phase. Because in single phase, we have only single phase. There is no any phase displacements. In 2 phase, 90 degrees. In 3 phase, 120 degrees. 120 nothing but 2 pi by 3. In n phase, 2 pi by n. These are very important one.